All right, hello there, hello. Welcome to CXC Math TV, and today we're going to be looking at the Pure Mathematics Unit 1, and this is, of course, the 2023 paper that we did in June. All right, so this is last year paper. All right, so we're just going to go through everything slowly. So if you're using this video as a practice, you just want to see if the solution is correct, and yeah, we go through it very thoroughly here. So the first question, it says let P and Q be any two proposition. Complete the truth table below. So this arrow mean implies, of course, and it says P implies Q. So P implies Q. It is only false when P is true and Q is false. That's the only time it is false. Every other time it is true. All right. So this is where P is true and Q is false right here. This is the only time it is false. Everywhere else is true. Over here now, we're looking for when Q is true and P is false. That's the only time it is false. So look, when Q is true and P is false, that's the only time it is false. Everywhere else is true. Cool. Now, once we have that out the way, now it wants P implies Q and Q implies P. True and true is true. False and true is false. True and false is false. True and true is true. And that's it. Nice. It says, hence, state whether the statements Q implies P and P implies Q and Q implies P are logically equivalent and justify your answer. Now, are they logically equivalent? No. Look at why. Let me change the color. Look right here. This is Q implies P, and this is the other statement here. Right? Now, looking at those two statements, they have different truth values. Notice true, true, false, true, but this one is true, false, false, true. Different truth values. So we can tell them the two statements above are not logically equivalent since they have different truth values. That's it. All right. Now part B. Part B says let x and y be negative real numbers and z be any real number. Use a counter example to show that the statement x, if x is greater than y, then x times z is greater than y times z. Notice they said use a counter example to disprove the statement. Anytime you're showing something is false, you're disproving the statement. So in this case, I will just say let x equal, let's say x is negative any real number, all right? X and y is negative real numbers, that's key. So I would say let x be negative 1 and y be negative 3. So we know that negative 1 is greater than negative 3, so x is indeed greater than y. Now, after that, now, z, right? Afterwards, now, z, and z can be any real number. So look at this now. So let z be equal to even negative 4. So if z is negative 4, right? In this case, look at this. X times z is equal to negative 1 times negative 4, which is 4. And then we notice that y times z would be equal to negative 3 times negative 4, which is 12. Now in this case, what can we conclude? Now x times z Is it greater than y times z? No, that's false because 4 is not greater than 12, right? So 4 is not greater than 12. So in this case, we can tell them, therefore, the statement, if xy is x is greater than y, then xz is greater than yz is not true. Well, it's not always true. That's our statement you should put. Alright, but this is okay. Part C. It says the expression f of x is a cubic polynomial that's divisible by 2x minus 1. First thing, once they tell us it's divisible by something, then write down what we know. Automatically, you'd set 2x minus 1 equals 0. Transpose for x and you get x equal half. Since it's divisible, they're telling us f of a half is equal to naught. So we're going to put it in our calculator. So we're going to put 6 times a half cube plus p times a half square plus q times a half plus 2 equal naught. Now let's just simplify. This is easy, very easy. So simplifying, well, I'm just going to use the calculator. It's early days. Early days in the exam, you want to use a calculator to keep your brain fresh for when you reach module 3. So in this case, we get 11 over 4. So that's 11 over 4 plus a half. When you square it is a quarter. Half when you square it is quarter. And quarter times p is p over 4. Plus q times a half is q over 2. That's equal to 0. Remember, add the 6 times a half. When we cube it, remember I added the 2. Now, I'm going to multiply through by 4 just to simplify the equation to get 11 plus p plus 2q is equal to 0. Now the next equation now, they told us it has a remainder of 2 when it is divided by x minus 1. Right? So in this case now, they're telling us that f of 1 is equal to the remainder and the remainder is 2. So since the remainder is 2, that means 6 times 1 cube plus p times 1 square plus q times 1 plus 2 is equal to 2. The 2's on both sides cancel, so 6 plus 1, 6 times 1 is 6 plus p plus q is equal to 0. When you bring this 2 over here, it cancels. So now we have our two equations. We have this equation, I have our other equation over here. So I put it around, I put it inside the black box, right? So now we can go ahead and do either addition or subtraction, however you want to do it. So I connect them right here and I'm going to subtract. So now I do my subtraction, right? So 11 plus p plus 2q equals 0. 6 plus p plus q equals 0. I subtract. 11 minus 6 is 5. P minus p gone. 2q minus q leave plus q equals 0. And so q is negative 5. Since q is negative 5, I can plug it in any one of the equations. I'll use the one at the top that says 6 plus p plus q, which is negative 5 equals 0. 6 plus negative 5 is really 6 minus 5, and 6 minus 5 is 1. This is saying p plus 1 equals 0, so p is negative 1. Now, since p is negative 1, we can conclude, therefore, p equal negative 1 and q equal negative 5. Now, what I always suggest is verify your answer. And look how you verify your answer. Write out what the function would be, right? So, right here, let me zoom out. We finish off this question, and we have this. So, write out what the function would be. So the function would be f of x is equal to 6x cubed plus px squared, but p we said is -1. Let me put it here. So we're saying this is now 6x cubed minus x squared. Q is -5, so minus 5x plus 2. So what I'd love you to do is take out a calculator and ask the calculator to solve that cubic equation. One of the answers you're supposed to get is a half. If you don't get a half, you know something is wrong. So equation, cubic, A is 6, B is -1, C is -5, D is 2. Solving it, we get -1 as the answer. We get 2/3 as an answer and half as an answer. Since we get half as an answer, we know we're correct, all right? We know we're good to go. So we didn't make any mistake. And of course, you could verify it also by plugging in 1 in this equation. You're supposed to get your remainder being 2. So that's out the way. Now this question, it says solve this log equation. Very simple log equation. So we're solving log base 3 of x squared minus 9 minus log base 3 of x plus 3 equal to 3. Now, if you practice questions from the Macmillan textbook, you'd see this exact question in the Macmillan textbook. Literally, they take it from the Macmillan textbook. It's that easy. So start practicing from the Macmillan textbook, the one pure math textbook that basically run the entire Caribbean. Practice from it. Guarantee you might see 1 or 2 questions. And if it's not the same question, they just change up something minor. So in this case now, write it as 1 logarithm. It says log base 3 of. Once you see subtraction, you know that you're dividing. So this is really x squared minus 9 over x plus 3 equal to 3. What we know is that x squared minus 9 is the difference of 2 squares. That's x minus 3 times x plus 3 over x plus 3. And this is equal to 3. Now in this case, now we notice that x plus 3 over x plus 3 cancel each other. And so what we're actually solving now is log base 3 of x minus 3 equal to 3. Then the rule of logarithm says number is equal to base to a power. So what is logarithm? A power. What's the power? So notice the base is 3 and the power is 3. So that means x minus 3 is equal to 3 to the third power. And so if we bring over this minus 3, it becomes plus 3. And 3 cubed is 27. And then we have the plus 3 here. So x is just equal to 30. That's the answer. You can always double check it. To double check it, bring out a calculator. Put x as 30 in. So log base 3 of bracket 30. When you square it, then you subtract 9. Close that bracket. Minus, well, that's fine. Then we have minus log base 3 of 30 plus 3 is 33. Notice you get a 3. So you realize x being 30 is indeed correct because we get our 3. Nice. This part, it says, again, this question is also taken straight from the Macmillan textbook. Please make sure you practice from the Macmillan textbook. So for this question right here, right, they ask us to find, show that it simplifies to be that this is laws of indices really. So we have the square root of 320 x cubed plus the square root of 125 x cubed. Now, first thing, take out a calculator, square root 320, simplify that part. Square root 320 is 8 root 5, but just to show them the working, you can tell them this is the square root of 64 times the square root of 5, and then x cubed. Alright, this is now, look what we're going to write. X cubed is really the square root of x squared times the square root of x. So break it up. X cubed is x squared times x. Plus this part now, we're saying the square root of 125 is the square root of 25 times the square root of 5. And x cubed, we already said, is the square root of x squared times the square root of x. Next thing now, the square root of 64 is 8. I'll put back our root 5. But then when we square root x squared, we get x. And then we can't simplify square root x anyway. Then this part now, square root 25 is 5. We can't simplify root 5. Square root x squared is just x. Square root of x, we can't do anything to that. So we can put back the square roots together. So instead now, we're going to write 8x square root 5x plus 5x square root 5x. But 8x plus 5x is 13x square root 5x. Because think of square root 5x as apple. So 8x apple plus 5x apple is 13x apple. And that's it. How many marks for that? I would give that 2. 4 they give. So they give 4 marks. That means you have to show the work here. So you notice to show them the detailed work here. This question says show that the function is bijective. A bijective function is a function that is both one-to-one and onto. So a bijective function is both one-to-one and onto. Alright, now they didn't give us a range, so that we can do it the 2 ways. Method 1, you have the graphical approach, which I like to do. I like the graphical approach. Come on, hurry. Alright, so with the graphical approach, all you pretty much do is sketch the function. So let's sketch the function here. So I draw a little graph. F of x is 7x plus 2. So it passes through, I think that would be negative 2 over 7. And the y-intercept is positive 2. So something like this. Alright, this is our 7. Since it's a sketch, let me make it more. Let me make it less drawn to scale. So this right here is our negative 2 over 7. This right here is our plus 2. And this is the graph of y equal to f of x. Now, if we do what we call our vertical line test, not vertical or horizontal line test, we do our horizontal line test, we realize that for horizontal line, it only detects one point of intersection for all x values. So our horizontal line only intersects the curve at one point, and so the function is one-to-one, and since all x values, the horizontal line test detects only one y value, detects a y value and only one. Hence, the codomain equal the range, and hence f of x is onto, or some might say surjective. Since it is both onto and injective, Thus, f of x is bijective. So that's it. That's how we prove that it's bijective. Alright? It's bijective. So our horizontal line only intersects the curve at one point. The black line you see right there, that's your horizontal line. I like method 1, they give them a little explanation. Alright, now method 2 is the computation approach, which a lot of people gonna solve f of a equal f of b. And so we have 7a plus 2 equals 7b plus 2. So we get 7a equals 7b. The 2's cancel, and so of course a is equal to b. So hence we conclude f of x is injective. Then of course now for surjectivity we solve f of a equal b. And we notice if we have 7a plus 2 equal b and we make a the subject, we get a is 7 minus b over 2. And we notice then for all a there exists a value for b, and that is for all a and b being real numbers. And then we conclude, write it here, so we conclude hence f of x is bijective. Since it's both onto, hence f of x is onto, thus also bijective. It's bijective since it's both onto and one-to-one. So I mean, easy question to start, easy 5 marks, no problem. Now it says, we just did that, sorry, see there, we just did this part. The picture is there twice. This part now it says, the roots of a cubic equation, determine the equation with root 1 over alpha, 1 over beta, 1 over gamma. Whenever you get these questions, you always start by writing down alpha plus beta plus gamma first. Now always remember it's minus b over a. So it is minus negative 1 divided by 3, which is 1 over 3. The next thing you proceed to do is write down alpha beta plus beta gamma plus alpha gamma, which is c over a, which is negative 2 divided by 3. Then you write down alpha beta gamma, which is minus d over a, which is negative 1 over 3. The next thing you proceed to do next is you find out the new sum. So the new sum is going to be what? 1 over alpha plus 1 over beta plus 1 over gamma. Always do what now when you reach this point? LCM. When you do your LCM, we notice the LCM is going to be alpha, beta, gamma. Alpha into these, leave beta, gamma. Beta into the denominator, leave alpha, gamma. Gamma into the denominator, leave alpha, beta. And so in this case now, we can just evaluate. So we look at it right there, we put in negative 2 over 3, and we divide it by alpha, beta, gamma, which is negative 1 over 3. And of course, you'd work it out, but don't know why I'm putting this in the calculator when we know what cancels. So it should be, it's okay. We know that the denominators right there cancel because when you divide, you flip, but you know, that's okay if you put in a calculator. That's 2. Now, after we get the new sum, right, I like to call sum S. Then we need to find the pairwise product. So I like to call it P1. We need to find P1. P1 is 1 over alpha times 1 over beta plus 1 over alpha times 1 over gamma plus 1 over beta times 1 over gamma. That's what I call P1. Let us zoom out a bit. Now, let's find P1. So again, we find the LCM, and the LCM is going to be, again, alpha, beta, gamma. Now, alpha, beta into this leave gamma, then alpha, gamma into this leave beta, beta, gamma into this leave alpha, which is just the sum. So we would put in 1 over 3 and divide it by negative 1 over 3, which would just be negative 1. That's our P1. Next we need to find is our new P2. Our new P2 is going to multiply 1 over alpha times 1 over beta times 1 over gamma, which is 1 over alpha times beta times gamma is negative 1 over 3. And then we work out 1 divided by negative 1 over 3, which is negative 3. So put that in the calculator and we'll get negative 3. Once you have this, all you have to do now is put it together. Remember the equation now for a cubic. So the equation for cubic. The equation for your cubic is x cubed minus the sum of the roots times x squared. Then we have plus p2x, p1x. Then we have minus p3 equals 0. That's the equation of our cubic. So in this case now, to write down the new cubic equation, we look at S, which is our new sum. X cubed minus the new sum we said was 2. That's 2x squared. Then P1 minus 1, so minus x. Then minus P3. And P3 was negative 3, so minus and minus become plus. And that's your new cubic equation. Is the answer. Usually this is about 8 marks. Now do not ignore the equals 0. If you ignore the equals 0, they ignore a mark, because look what I'm saying. If you write this, x cubed minus 2x squared minus x plus 3, this is a cubic expression and not a cubic equation. They want an equation, put your equals 0, please. That's 8 easy marks. As I said, it's usually 8 marks. Every year it's there. This question, it says the diagram below shows a graph of x squared plus 6x plus 8. So we know this is a quadratic and them give you the graph. They didn't need to give us the graph to give any question with this, because from this we can factorize x plus 2, x plus 4. We get the roots. Whatever they're asking, they didn't need to give us the graph. It says though, on the axis provided, sketch and label the modulus of x squared plus 6x plus 8. Always remember modulus. Whenever, how I want to put it, whenever you have modulus, right, modulus values are positive. So whatever is below the x-axis is going to become above the x-axis. So right here, which is a turning point, it's going to end up be right here when we reflect it over the x-axis. This is the x-axis. So in this case, how the modulus is going to look when we sketch it, everything else is going to remain the same. So I'll use this color. Everything else turn the same. So this would be the modulus region. Now my sketch is off. Then now we shade in here. That's it. Easy 3 marks. 3 marks to sketch that. That's so easy. It says on the same axis, sketch the inverse of f for x being greater than minus 3. So we need the inverse function. Now to find the inverse function, right? By the way, always remember the inverse. You don't even need to sketch it. The inverse is always a reflection of the curve in the line y equal x, but I prefer to find the inverse function. So if we have y is equal to x squared plus 6x plus 8, I notice that we can complete the square first. This is x plus half the coefficient of 6, that's 3, square, subtract whatever number is here, square plus 8. So in that case, y is x plus 3 square minus 9 plus 8. Minus 9 plus 8 is negative 1. You didn't need to do that. You would know that the turning point was already negative 3, negative 1. You should know that from your graph. Your graph would tell you, see there, negative 3, negative 1. Your graph would tell you that, but I wanted to complete the square and show you. Why? Now you can find the inverse easy. Because now all you're going to do is interchange x and y. So x come here. Is now y plus 3 square minus 1. Add 1 to both sides. So x plus 1 equal y plus 3 all square. Then we square root. So square root x plus 1. This is y plus 3. And then we bring over. So in this case, when I bring over the 3, it becomes y equal square root x plus 1 minus 3. This is the inverse function. Square root x plus 1 minus 3. Why did I write down the inverse function? Why did that now? Because they told us to sketch the graph for this. So this is how we're going to sketch the graph. And notice they say we sketch the graph for x being greater than what? For x being greater than negative 3. That's where we start. Now you notice if you put in negative 3, you can't square root negative 3. So you have to actually start from where? Negative 1. You're going to have to start from negative 1. So we're going to have to start from negative 1. So when you plug negative 1 here, in order, I really want everyone to follow what I'm saying. I know some persons are following and say, yes, sir, we're good. But what I'll do is I'll go back to what you do in C-sec. Alright, so in C-sec, this is what you do. You have your x values, and notice we have negative 1. So the inverse value, you put it in the function right there. So you bring out a calculator, and you put in square root, you put negative 1 plus 1, leave the square root, then put your minus 3. You put that in the calculator, notice you get negative 3. So when x is negative 1, y is negative 3. When x is 0, when you put 0 here, you get 0 plus 1 is 1. Square root of 1 is 1. 1 minus 3 is negative 2. And just to fast forward, I just want you to get a general idea of what's happening. When you put a number like, let me see, 2. Put a number like 2. I know you have 1 here, but you put 2. Alright, then I'll put 4. There's a reason why I'm skipping. Alright. Now, if you put 2 here, 2 plus 1 is 3, square root 3. Well, that's not working out to smooth. I want a smoother number. Let's put 3 here. 1, 2, and 3. When we put 3 here, 3 plus 1 is 4. Square root of 4 is 2. 2 minus 3 is negative 1, right? So now we can sketch it. Alright, we get the idea. Look what I'm saying. Look what I'm saying now. So when x is negative 1, y is negative 3. Right here, this is the inverse in red now. When x is 0, y is negative 2. When x is all the way at 3, y is negative 1. The inverse is a reflection in the line y equal x. So all you're going to do is draw a smooth curve connecting it like this. Alright, and it passed through at 8, so we know it would have cut the x-axis at 8 somewhere there. Alright, so if this had continued, this would be the number 8. Alright, and that's it. All you can do now is maybe you want to put on the line y equal x for them. Even though that really doesn't matter, but you can put on the line y equal x. So you draw the line, let me see, 4, 4. And you draw a straight line. I won't be able to draw it so straight, but you should draw a straight line and label it y equal x. This is the inverse right here, f inverse of x. Easy 5 marks. Easy, easy, easy. Alright, so just to zoom out and just discuss it one last time. Remember, step 1, what we did, find the inverse function. Step 2, you then now plot. You're basically plotting points, starting from the domain being negative 3 But we notice that we can't start from -3 because you cannot square root a negative number. So since we start from -3, we notice -3 and -2 cannot work here, so we really start from -1. That's it. It's very easy. 5 easy marks. It says, given that g of x is this function, prove that g inverse of 2 doesn't exist. So first thing, g of x is 2x plus 3 over x plus 3. I'm going to show you method 1 first. Method 1. Look at this. If g inverse of 2 does not exist, then what we're saying then is g of x equal to 2 has no solution. So that's what I'm going to verify first. I'm going to verify if you solve g of x equal to 2, you're not going to get any solution. That's the first method I want to do. So let's do it now. Right? So here is the verification. So we're solving 2x plus 3 over x plus 3 equal to 2. Cross multiply, we're getting 2x plus 3 equal 2x plus 6. 2x cancel, so we're getting 3 equals 6, which is madness. We know 3 can't equal 6, right? And so from that, no solution. Easy. This is just so easy to write on the paper for 4 marks. But that's not the approach that many persons might take. The approach that many persons might take is they might do it this way. To show the inverse of 2 doesn't exist. So this is now method 2 in purple. M2 mean method 2. So many persons might end up saying, since we have g of x, let's find the inverse actually. I think this is too long though. So now y is equal to 2x plus 3 over x plus 3. So if we interchange x and y, we have x is equal to 2y plus 3 over y plus 3. They will need to make back y the subject. So in this case now, we cross multiply, so xy plus 3x is equal to 2y plus 3. And then now we can factor out, so xy minus 2y equal, bring over the 3x to the other side, that's 3 minus 3x. In this case, we factor out y, we have x minus 2 equal 3 minus 3x. Divide through by x minus 2. So we have 3 minus 3x over x minus 2. Once we have the inverse, and guys, by the way, you see why I don't like method 2? Method 2 is just so strenuous and long. Look at this. We're still not finished. So now up here, we're going to say, now that we have g inverse of x, which is 3 minus 3x over x minus 2, then now we need to input x as 2. Inputting x as 2, we have 3 minus 3 times 2 over 2 minus 2, which is 3 minus 6 is negative 3 over 0. But anything divided by 0 has no solution. So since it has no solution, it does not exist. Well, I shouldn't say no solution. It has no real solution. That's the correct terminology. But that's a term for unit 2. Real solution, but we're not there yet, so we'll leave it at that. Alright, so we'll finish module 1 and on to module 2. Module 2, it says we need to prove this trigonometric equation here. We're doing trigonometric proof, we always start from our left hand side. 1 minus sine theta over 1 plus sine theta. Anytime you get something like this where you notice that the conjugate of the numerator is in the denominator, just rationalize. So multiply by the conjugate of the denominator. And if we multiply by the conjugate of the denominator, 1 minus sine times 1 minus sine become 1 minus sine theta all squared. And then the denominator going to become the difference of 2 squared, which is 1 square minus sine squared. Now we can expand the numerator, first term square, twice the product of the 2, that's 2 sine theta. Second term square, that is sine squared theta, over In this case now, we notice that we have what is this? 1 square minus sine square. This is cos square theta. So now we have cos square theta right there. Easy. Now looking at the numerator, we're trying to generate sec theta minus tan theta. So I like to look at what we have. Remember, sec is 1 over cos theta. And I know that tan is sine over cos. So we really have 1 minus sine theta all. This is what we really have, right? So in that case now, we're like, okay, this is easy. So my apologies, we didn't need to do this then. Keep the numerator as 1 minus sine theta all square. Then we're going to put the denominator as cos theta all square. So what we're saying then is this is 1 minus sine theta over cos theta, and this is all being squared. Then inside of the bracket now, we can separate it as 1 over cos theta, then minus sine theta over cos theta, and this is being all squared. Now 1 over cos, we know 1 over cos is our sec, and then sine over cos is our tan, and it is being all square, and we finish, which is our right hand side. Easy. You do this question and you tell them that was ridiculously easy. Alright, so 9 marks. It's easy 9 marks, no problem. It's not so bad. We take that 9 marks. I don't see why it's 9, but they give it 9. The next part, this is an add maths question. Solve this trig equation. Now, anytime you see square with cos and sine, you need it to be in terms of one variable. Now, since it has sine x here, we're just going to change the cos square theta to 1 minus sine square theta. That is all. It's become 2 in bracket 1 minus sine square theta. I don't know why I keep saying theta, it is x. 1 minus sine square x minus 3 sine x equal to 3. Expanding the bracket, this is 2 minus 2 sine square x minus 3 sine x equal to 3. No need to go ahead and group up like terms. So, or I don't know how you want to do it. I like when everything is to the right instead of going to the left. So 2 sine square x minus 3 sine x. And when I bring over negative to the other side, it's plus. When I bring over minus 3 to the other side, it's also plus. When I bring the 2 to the other side, it's really, when I subtract 2, 3 minus 2, this is now plus 1. Now, many persons like to say let y or m or whatever, let m equal sine x. So you see that it's really just a quadratic equation. So it's really just 2m squared plus 3m plus 1 equals 0. From there, you can proceed to factorize 2m, m, 1 and 1. Signs are the same, both positive. Right? So that means m is just negative a half, and over here m is negative 1. But they didn't give you any variable called m. They gave you sine x. So you're going to have to resubstitute back m as sine x equal to negative half, or sine x being negative 1. Now, in this case now, we're going to solve for x. But remember your circle, right? Remember all school teachers care, right? And so in this case now, remember, since we're negative, we're at the bottom too. So if you sine inverse half, let me just bring it up for you. If you sine inverse half, you get 30 degrees, or some might say pi by 6. That would be a first quadrant answer. But we need third quadrant and fourth. So x is then equal to, remember down here is pi plus pi by 6. Here is 2 pi minus pi by 6. Over this side, if you sine inverse 1, you get what? Check it in a calculator. If you sine inverse 1, you would get 90 degrees or pi. So in this case now, your answers is going to be pi plus pi, or this is what now? Wait. Negative 90 degrees is pi over 2, sorry. So pi plus pi over 2, sorry. And right here is 2 pi minus pi over 2. So just to write out all the answers now, you evaluate this. Pi plus pi over 6. No, this is being lazy. No calculator. 6 plus 1 is 7. So that's 7 pi over 6. Comma. Multiply 6 2 is 12. 12 minus 1 is 11. So that's 11 pi over 6. Here, multiply 2. 2 plus 1 is 3. And we have 3 pi over 2. Yeah, that's our answers. Now, remember, if you get the same answer, you don't need to write it twice. So that would be the solution for this question. Easy 9 marks. I don't see why this is on a pure math paper. It's really hard math, but we take it. We take it. We're not complaining. So the next question now, it says we need to show that this is equal to negative sine x. So this is just compound angle. Remember, when you're doing a proof, you start from left. So left hand side is cosine pi over 2 plus x, which is cosine pi over 2 cosine x. Then we have minus sine pi over 2 sine x. But then we know that cos pi over 2 is 0. So this is now 0 times the cosine of x minus sine pi over 2 is negative 1. Just to write here, just to make sure I have the right thing. So cos A plus B is cos. Then we have minus sine, yes. And sine pi over 2 is 1. And then we have sine x here. 0 times cos x is 0. Then negative 1 times sine x is just minus sine x. Pen not writing. The mouse is moving, but the pen is not writing. Let me try again. Unplug. Right. It is now minus sine x. And 0 minus sine x is negative sine x, which is your right hand side. Very easy. It's not too bad. It's not difficult. It's not that challenging. 4 easy marks. Alright, part D, I'm sorry it's not showing so good. It says A and B are acute angles, and they tell us that sine A is 3 over 5. If sine A is 3 over 5, draw a triangle. And it's acute, by the way. Acute means it's less than 90 degrees, between 0 and 90. And they tell us that the opposite is 3 and the hypotenuse is 5. So clearly the adjacent is 4. Then we have another triangle, cos beta. And they tell us that the adjacent is 5. The hypotenuse is 13. And now we need to work out, without a calculator, without using tables or calculators, all right, we need to evaluate cosine A minus B. Now, in this case now, cosine A minus B is equal to cos A cos B plus sine A sine B. So cos A, look at the diagram with A, 4 over 5. Cos B was given 5 over 13. Plus sine A we said was 3 over 5. Then sine B, this would be 12. So that's 12 over 5. Now, 4 5 is 20, so that's 20 plus 3 times 12, I believe that is 36. I strongly believe that's 36 over um 2 over 13, sorry. 5 times 13 is, I believe that's 65. I hope I'm correct there. And 20 plus 36 is 56. 56 over 65, and that's the answer. Now for verification, we're going to use our calculator. Like, what's wrong if we use our calculator? Look how we're going to use our calculator, right? So this is just verification. It's already finished, you know, guys. It's already finished. But just to verify it, we're saying then cos A minus B is equal to cosine of. If you wanted to find A, you'd sine inverse 3 over 5. So it's cosine, please pen start to write, sine inverse 3 over 5 minus, if you wanted to find B, B would be cos inverse 5 over 13. So this is just with our calculators. We're going to see if we're correct. So we should be able to put this in our calculator. We should be able to just say, I want to find cos of sine inverse 3 over 5, and then I want to subtract cos inverse 5 over 13, and then 56 over 65. Voila. So you can do that and get your answer. It doesn't really matter. It's up to you. By the way, this you cannot do this and get a, if you do this, you only get 1 mark. If you do this, you get 1 mark. Remember, this is a verification. This is using calculator. They don't want to see you use calculator. What they're looking for you to do is to do this right here. Know your trig ratios. Alright, question 4. Obtain Cartesian equation. We love when it's this simple. So in this case now, if we divide by 3, we have x over 3 is cosine t, and y over 4 would be sine t. Now we need to get rid of the parameter t. But what we do know is that sine squared t plus cos squared t is equal to 1. So in that case, it is y over 4 square plus x over 3 square is equal to 1. Because it's 5 marks, I wouldn't stop here. X square over 16 plus y square over 16 plus x square over 9 equal 1. Then the LCM of 9 and 16, I believe, I think it's 144. The LCM is 144. So if we want, we can simplify, give them the simplified answer. Multiply this by 9. This is 9y squared plus multiply this by 16. This is now 16x squared equal the 16 times 9, which is 144. That's your answer. Alright, this right here. Alright, 5 easy mark. Alright, part B. They say the equation of a line is x equal this equal this, and this equal to this. Alright, so since we have all of these, determine the point of intersection. So remember, it's basically simultaneous equation. You substitute the line into the plane. Alright, to find the point of intersection, we sub line into plane. It's very easy. So where x is 2 plus t. So put 2 plus t. Well, let me just write it out. X plus 2y plus z equal 12. X is 2 plus t. I'm underline it there in red. In black now, underline in black, y is 1 minus 3t. So I'm going to have plus 2 in bracket, 1 minus 3t. Then now I use a different color for z. Z is 4 plus t, so plus 4 plus t equal 12. Now expand, we have 2 plus t plus 2 minus 6t plus 4 plus t equal 12. Then 2 plus 2 is 4, 4 plus 4 is 8, then t plus t is 2t, and 2t, just to underline it, it's easy there, t minus 6t plus t, that's negative 4t, equal 12. I will then solve for t, so bring over and bring over. So 8 minus 12 is equal to positive 4t. Just because I'm bored, I'm going to divide through by 4. You don't need to do this. I'm just bored. Divide through by 4. So 2 minus 12 divided by 4 is 3 is equal to t. And so t is negative 1. Now when you get t equal negative 1, you just get the parameter t. So when t is that value, that's when the line will intersect the plane. So we can tell them at t equal negative 1, x, remember, is 2 plus t, which is 2 minus 1, which is 1. Y is going to be 1 minus 3t. So it's 1 minus 3 times negative 1, which is 1 plus 3, which is 4. And z is going to be, z was what again? I think 4 plus t. And so it is 4 minus 1, which is 3. So therefore, the intersection point is 1, 4, 3 is our intersection point. 1, 4, 3, that's the answer. Alright, this right here, 1, 4, 3, that's our answer. Just to check again, 2 minus 1 is 1. Remember, we'll put t right here as negative 1, so this is 1. Negative 1 times negative 3, positive 3, 1 plus 3, 4, and 4 minus 1 is 3. This is our point of intersection, 1, 4, 3. Now it says determine the vector equation of the plane passes through 1, 5, negative 1, which is perpendicular to 2, 4, 3. Always remember vector equation of a plane. So first, r dot n equal a dot n, where this is just r dot, the normal to the plane, which is any line that's perpendicular to the plane, so 2, 4, 3, equal a, any known point on the plane, the 1, 5, negative 1, dot product with the normal. And we work this out now, 1 times 2 plus 5 times 4. Then we have plus negative 1 times 3. And then now we just take it from there. And this is r dot, I'm going to put it another way. I'm going to write it as 2i plus 4j plus 3k. So in that case, our vector equation is going to be r dot 2i plus 4j plus 3k equal to 1 times 2 is 2, 5 times 4 is 20, and I'll just put all of it in the calculator. 2 plus 20 plus 1 negative 1 times 3. Alright, when you get in a little bit tired or fatigued, you start using up your calculator, because we are prone to mistakes as humans, and that's fine. Don't beat up your chest. It's okay to make mistakes, alright? We're just humans. It's okay. Or if you want to put it in Cartesian form after, you can write 2x plus 4y plus 3z equal 19. Alright, now afterwards it says, hence determine the coordinates of the point in the plane where y equal 3 and z equal 1. So all we're going to do then is, when y equal 3 and z is equal to 1, we're getting 2 times, we don't know the x value, but we have 4 times the y value is 3, and 3 times the z value is 1. We know that is 19. We'll put it in the equation of the plane right here. In this case now, we'll plug this in. We're getting 2x plus 12 plus 3 equal 19. Bring over the 12 and bring over the 3. So 2x is 19 minus 12 minus 3. 19 minus 12 is 7. 7 minus 3 is 4. 2x is 4, and so x is 2. Now, since I get x is 2, then the coordinate point is x comes first, y comes second, z comes last. 2, 3, 1. That's it. 2, 3, 1. All right, kids next door. All right, so that is that. Now, part D, it says, given that a line to a vector u and vector v is normal, calculate the angle between the line and the plane. So given that a line, all right, no problem. This question is looking nice. Let's read it again. Given that a line u and vector v is normal to the plane, right? We need to calculate the angle between the line and the plane. So remember they told us what? That the line is parallel to vector u. The line is parallel to this, all right? Now, since the line is parallel to this, that means the line is also going in this direction. And then now, and the vector v is normal to the plane. So what we're saying is, we have the plane and we have the line, all right? And they want us to find the angle between the line and the plane. This is the line and this is the plane. We need to find the angle. Let's call the angle beta. All right, so we're going to tell them let beta be the angle between the line and the plane. Now, one thing that stands out is every time when you do questions with this, persons always think to write this down. Cos beta is A dot B over magnitude A times magnitude B. If you did this, you're wrong, and I'm sorry. Now, what happens is whenever you have line and plane, you don't use cos, you use sine. All right. I think I would have uploaded a vectors video explaining. If you go back and watch the vectors video from a long time ago, we actually go through the proof of all of these stuff. Go through when you have questions where you're finding angle between line and line is cos. When you find angle between planes, then you work out the angle between their directions, or actually the normal to it. All right, and you use cos, but when it is line and plane, you use sine. So, I mean, we have a vectors video on that, so we're not delving into that. So in this case now, what is A and what is B? A is the direction of your line, all right? So in this case, we're going to work out 1 minus 3, 1, the dot product with 1, 2, 1. This would be 1 times 1 plus negative 3 times 2 plus 1 times 1. That's going to be 1 plus 1 is 2. Then negative 3 times 2 is minus 6. And 2 minus 6 is negative 4. Then now we're going to work out magnitude of A. So magnitude of the direction. So magnitude of, I'll just call it A since I started with A. Square root 1 square plus negative 3 square plus 1 square. 9 plus 1 plus 1 is 11. I'll leave it at that. B is square root 1 square plus 2 square plus 1 square. And that is 4 and 1, 5. 5 and 1 is 6. Square root 6. Alright? So in that case now we can work out the sine of the angle. So sine beta, as I said, is the dot product. And the dot product we got was, where is it? Negative 4. So it's negative 4 over square root 11, square root 6. And so that means beta is equal to, then we'll put this in our calculator, -4 over square root 11 times 6. This is what we get, and then we'll sign inverse it. Oh, my calculator is in radians. I want the degree answer. So I'm going to have to do it again. Sine inverse fraction, -4 over square root 11 times square root 6. And so put that in the calculator, and we'll get -29.5 degrees. So that's it. Always give your answer to 3 significant figures. So that's the angle between the line and the plane. That's -29.5 degrees. Alright, negative just mean always remember positive and negative, you take into account the direction. That's all. Alright. Now, module 3 now, not so bad. Module 3 is limits and continuity, differentiation, and integration. When you get these questions, you can just, there's 2 ways to do it. Method 1 is divide through by the highest power. So the limit as x approach infinity, you divide through by the highest power of x, so you divide through by x to the 4 over x to the 4. So when we divide through by the highest power, it becomes the limit of 2x cubed divided by x to the 4, it becomes 2 over x. This becomes minus 4 over x divided by x to the 4, leave x cubed. Then we have 1 over x to the 4. Then this is 3. X squared over x to the 4 is 1 over x squared. Then minus 2 over x to the 4. Then we plug in infinity. 2 over infinity is 0. 4 over infinity is 0. 1 over infinity is 0. And if you have 0 in the numerator, then 0 over anything is 0. So the limit is 0. Easy. How many marks? 5 easy marks. That's method 1. So in that case, you just divide through by the highest power. Now method 2, what you do for method 2 is you can just try a value. Try big value. Since it says x approach infinity, you can try x equal 10 million. Let's try x equal 10 million. So we get 2x. Now 10 million is a big number. So you put in 2 times 10 million cube minus 4 times 10 million plus 1 over. You're just trying, right? You try big numbers and you'll get an idea of where the function is approaching. You'll get an idea of the limit. Hopefully you're using a good calculator that the calculator could give you an idea. If the calculator can't give you an idea, use a number like 1000 then. So let's see if my calculator can give me a good idea. So I said I wanted to use 10 million. Is this 10 million? 1, 2, 3, 4, 5, 6 zeros. Need one more. This is 10 million right there. So now just to see, 2 times 10 million raised to the 4th power minus 4 times 10 million plus 1 over 3 times 10 million raised to the 4th plus 10 million square minus 2. Alright, so notice we get 2 over 3, no problem, with 10 million. So look what I'm saying now, right? So we know the limit is 0. Alright, so let's try another number. We try 10 million, let's try 30 million. and you'll get the idea of what I'm saying. It's eventually going to tend to a finite value. I guess this way going to be too lengthy. Let me see. 1, 2, 3, 4, 5, 6, 7. Yeah, that's 30 million. And then I'm going to show you the next way you can do it, which is L'Hopital's rule. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Alright, so according to what we are getting here, we're getting 2 over 3. So did I type something? I did type something incorrectly. The numerator was supposed to be cube, and the denominator is to the fourth power. So my apologies. My apologies there. We got to rectify it. Notice we're getting a small number that's approximately 0. And as you put in a bigger and bigger and bigger number, you're going to notice that it's going to pretty much be approximately 0. Look, so even if I change it to 60 million, notice we had 1 over like 450,000, which is basically 0. And even if we put a bigger number, it's going to get smaller and smaller and smaller. So realize that it's approaching 0. This is now what? 1 over super big number, almost 1 over infinity, which is what? 0. So that's what I wanted to show you, that this approach also works. So we'll put it, we notice we get approximately 0. And so we can tell them, hence, so we can tell them, hence the limit is 0. Hence, the limit as x approach infinity is 0. And as I said, that's method 1, method 2. You also have method 3, which is L'Hopital's rule, which all you do, L'Hopital's rule, you differentiate the numerator and you differentiate the denominator, and that's it. So differentiate the numerator, it would become, and we have in-depth video on what is L'Hopital rule, all right? So don't, if you're wondering what is L'Hopital rule, check out one of the L'Hopital rule videos. So this is now differentiate. Please, the computer is freezing. That's why I say me stop and scratching my head and all these things. It's freezing. All right, it's now better. So differentiate 2x cubed, we get 6x squared minus 4 over. Differentiate this, 4 times 3 is 12x cubed plus 2x. Now, when do you stop differentiating? You stop differentiating when you can plug in infinity. We still can plug in infinity because we're still going to get infinity over infinity. So we differentiate again to get 12x over 36x squared plus 2. Then we still can plug in infinity because infinity over infinity, we don't know. So we differentiate again to get 12 over 72x. Now plug in infinity, or you can realize 12 over 72 is 1 over 6x, which is 1 over 6 times infinity. So when you plug in infinity, 6 times infinity, 1 over infinity is 0. So that's another way you can do it. Just know that the answer is 0. Alright, part B, it says a student goes to a water cooler to drink some water. The student has a cup in the shape of a cone. So sometime like you go to the bank and they have the water cooler and the shape of the cup is in a cone, right? Just to picture real life. Sometimes you get math and you ask, why them doing this? Picture it real life. You go to the bank, you get the cone cup, and you know at the bank they give you either cold water or hot water, right? You pull up the blue button or you pull up the red button. So in this case now it says the water from the cooler is filling the cup at a rate of 12 cm cube per second. So for every 1 second, 12 centimeter cube of water goes in the cup, right? And it says if the height of the cup is 16 centimeters and the radius r of its circular opening, how fast is the water in the cup rising when the height is 4 centimeters? So first thing, this is a connected rates of change question. Now always start with the hint they give you. Once they give you volume, right? Once they give you volume, then you're good to go. You know that we're working out the rate. How fast is the water rising? How fast? All right. So since we're trying to work out how fast is it rising, all right? So we're trying to work out the rate at which it is rising, which is height. So we're trying to work out dH by dt, right? You need to work out dH by something times something by dt. Now, the hint that they give you is clearly the volume, V. So, we're going to work out dH by dV and then multiply it by dV by dt. And it's that easy. Now, V equal 1 over 3 pi r square h. So, I can multiply by, well, let me just differentiate with respect to h first. So dv by dh would be, I just drop off the h, basically that's 1 over 3 pi r squared. So if I want then, and I can rewrite this as pi r squared over 3. So if I want dh by dv, I would flip it, and this is 3 over pi r squared. All right. So I have that this is now dh by dv is 3 over pi r squared, and this is multiplied by dv dt, which is the rate, the volume rate. They must give you one of them. They said the rate of 12 centimeter cube per second, so they gave you that it was what? 12. Now, the next thing they gave us was, if the height of the cup is 16 centimeters, how fast is the water in the cup rising when the height is 4? Ha ha! Good question. Now, before we can go ahead, key thing, before we can go ahead and find dH by dt, we need to do something else. Notice they gave us the height, but they did not give us the radius. So what you're going to have to do is go over here now. Notice they gave us the height and the radius when it was something. I think they said the height is 16 and the radius is 8. We can use that to find the volume. So when the height is 16, they told us the radius is 8. So now we can use that to find the volume, which is pi r cube h. I think it's pi r cube h. Let me go back, or 1 over 3 pi r cube h. Whatever it is, I'm going to go back and look at it. 1 over 3 pi r square h. And so now all you have to do now is find the volume by input 16 and 8. So 1 over 3 pi times 16 times the radius, which is 8 square. And you put that in a calculator. 1 over 3 times 16 times 8 square. I'm not going to put the pi, so that's 1024 over 3. So the volume is 1024 over 3 pi. Why did I do that? I do that so now I would be able to find the radius when the height is 4. Remember, they did not give you the radius. They said how fast is the water in the cup rising when the height is 4. So now let's find the radius when the height is 4. So when h equals 4, right, we'll have the volume is equal to, this is the volume, 1024 over 3 pi. So 1024 pi over 3 is equal to 1 over 3 pi radius squared times the height, and the height here they said is 4. I need to basically make the radius the subject. So notice the pi is going to cancel each other. Pi cancel pi. The 3 in the denominator cancel each other. And then now we can divide by 4 to get the radius square is 1024 divided by 4. 1024 divided by 4 is 256. So r square is 256. So now we need to work out the radius here. Now this is going to give us the radius being 16, but we know that is off. So let me take off this here. Alright? Because look what happened. The volume is not going to remain the same. Alright? So when the height is 4 centimeters, let's look at it again. This is it here. We're focusing on right here when the height is 4 centimeter. My bad. This whole thing is 16. So right here would be 4. Right here would be 4. We need to find what this radius is. So we realize that clearly it couldn't be 6. Right? So we need to establish a relationship. We need to know what is happening. Is it that if the height decreases by 12 centimeter, how much will the radius decrease? What is this right here? Alright, so we can use similar triangles. That's one way to do it. Right, you notice right here, we have our triangle. There's many approaches to do it, guys. I'm going to use similar triangle. This is 16 and this is 8. Right, so the ratio is always what? A half. That ratio is a half. So in this case, when we decrease it now, and this side now is 4, and the new radius we want, the ratio needs to still be a half. So since r over 4 is equal to a half, alright, so therefore the radius is just 2. So now that we get that the radius would be 2 centimeter, now we can plug it in. So dh by dt is 3 over pi times 2 squared times 12, and then we'll plug it in. So this is fraction button, 2 square. Well, 2 square is 4, so that's 3 over 4 pi times 12. And then we can always simplify 4 into itself 1 time, 4 into 12 3 times. So this is just 9 over pi. So our answer is 9 over pi, and this is 9 over pi centimeter per second. Alright, that's it. That's the rate at which the water is rising. Alright. Now this question, it says a manufacturer of containers want to make a container in the shape of a cuboid. And it says the container is made from a flat sheet of metal 16 meters in length and 13 meters in width. So here's a flat container, and they tell us the length is 16 meters and the width is 13 meters. Squares of x meters are cut from each corner. So cut away x. So this piece come off, this piece come off, this piece come off, and this piece come off. So since we cut off all of that, they say now show that the volume is that amount. Now I'm going to show it here, right, with a piece of paper. I'll just make myself a little bit bigger so you can follow. So this is the piece of paper we have. Alright, this is the piece of paper. Alright, let me just make myself big just for now. So this is the piece of paper. What we do is we're taking out this piece. That's one box to take out. We're going to do it to each side. So we're going to take out this piece as well. Right here, we take out this piece. Take out this piece. So we'll take out this 4 squares, alright? When we take out the 4 squares, we'll be seeing it not fully here. But when we take out the 4 squares, right here, then now we need it to become a container. So you fold it up like this. Fold it up, So now we have what? Length, width, and height. The length is still this long part here. The length is just, notice we take off x and we take off x. So it is 16 minus 2x give it the length. Width now, remember, this side was the width. But this width now, we take off x and we take off x. So now the new width is now, what's the new width? The new width, we take off the x and the x. The new width, we take off this x and this x. Hope you can see we take off this x and this x. And so the new width is 13 minus 2x. And finally the height, remember we fold it up, the height is just what? X. So that's it. Alright. So now we can go back to working it. So in this case now we can tell them, so the volume is length times width times height. And the length is now 16 minus 2x times the width. 13 minus 2x times the height x. And they will just multiply from there. 13 times 16 times 13. I put that in my calculator. It's easy to work out, but you know, that's 208. 16 times 2 is 32x. 2 times 13, that's 26x. Negative times negative, positive 4x squared. Then all of this is multiplied by x. So now 208 times x is 208x. Negative 32 minus 26 is minus 58x. But then we times it by x, so it becomes x squared. 4x squared times x is 4x cubed. This is the expression above. It's just that we need to rearrange. So once we rearrange it, then we get to our answer. I'll finish. Now, once we do that, it's easy, we're done. 2 marks. Could have given 3, but they gave 2. This part, it says, using the method of second derivative, determine the height that will maximize the volume of the container. Always remember that if you want maximize in second derivative, it's d2. Second derivative, remember, is less than 0, right? That's basically it. The first thing we have v though. I don't know why I put height. I could have used the same v. So in this case, right? Oh, maximize the volume and not maximize the height, because the height is x, yeah. So in this case now, d2v by dx squared. V, remember we said was 4x cubed minus 58x squared plus 208x. So all we have to do now is first find dv by dx, which is 12x squared, carry down the power and subtract 1 from the power, minus 116x plus 208. Next thing now is you need to solve this equation equal to 0. Solve this equation equal to 0. Now, let's divide through by 12. Let's divide through by 12 to let the equation be simplified a bit. So, divide through by 12. So, we get x squared minus 116 divided by 12. That one looks so pretty. That's, oh, let's not divide through by 12. 12 not giving it a pretty. Let's use 4. 4 is in common. 3x squared minus 29x. And then 208 divided by 4. I think that's 52. Yeah, plus 52. Then we need to factorize this. 3x, x is the same. Signs are the same, both negative. Let's see. So if I put 26 here, if I put 26 here, and I put 2 here, would that work? Let me see. That is 6. No, this won't work. We're trying to get 29 in the middle. Alright? So, let me say 13 and 4. If I put 13 here, and 4 here, this is This is 12 and 13. That's not working either. I can't look at it and see it so easy. So I'm just going to use a calculator and solve it. So go to the calculator and put in equation. That's the day and age we live in, guys, where we are of the benefit of using calculator. So now we put in A is 3, B is negative 29, and C is 52. I'll solve it. That's why we couldn't factorize. We couldn't factorize it anyway. So in this case now, when we solve it, we're telling them x is equal to, just to not let it look no way, make it look like you use quadratic formula then. You don't want the examiner feel like you just put it in a calculator that give you the answer. So just to give the examiner, a little vibe, just put it in this way and then you can give him the answer that x is equal to, what's the answer we got? Depends. Do we want to work with this or do we want to work with the decimal? I feel a little bit better with the decimal, 7.29. Or the next answer we were getting is 2.38. Now, once you have these two answers, right? Once you have these two answers, we're going to verify which one is correct. Because one is going to be maximum and, well, one might be max and one might be min, but we want to focus on the maximum one, right? Now, just to make sure we're good, what I'm going to do is also solve this right here. Let's make sure we did it correctly. 3 4 is 12, 258 is 116, 208. We're good. Let's make sure we did everything right, alright? So now we can differentiate again to use second derivative. So d2v by dx squared is differentiate 12x squared, we get 24x minus 116. We're looking for the one that's less than 0. Clearly, when you put 7, it's greater than 0. So, only way for it to be less than 0. This is less than 0 when x is equal to 2.38 meters. Alright? So, in that case, determine the height. So, the height is 2.38 centimeter, and that will maximize the volume. Height is 2.38 centimeters when V is maximum. Alright, it says determine the maximum volume. Now, once you get the maximum height, it's easy to get the maximum volume. Right? It's easy. Because the volume formula now was 4x cubed minus 58x squared plus 208x. So all we do is plug in x as 2.38 in a calculator. And there you get your volume. It's so easy. You cannot ask for an easier question than this. I'll put that in our calculator. 4 times 2.38 cubed minus 58 times 2.38 square plus 208 times 2.38. So just to make sure we type it in the calculator right, I remember it was 4x cubed minus 58x squared plus 208x. Everything is good. Put in the calculator, we'll get 220.4. Just gonna put three significant figures, which is 220 meters cubed, not centimeter, meters cubed. And we're on to the final question now. So the final question, it says, calculate the volume of the solid generated by revolving. I can hardly see, so I know it's difficult for you too. Calculate the volume of the solid generated by revolving the region bounded by y equals 3x minus 6 and x squared plus 3x minus 2 on the interval 0, 1. So calculate the volume bounded by the region between 0 and 1. So this is what we're looking at, the volume between these region right here. As you can see, it says Microsoft Edge is not responding. So we're just waiting. It's going to stop soon. Just waiting. All right, it stopped now. So we need to work out the volume between this region. Now, in between, you always look at above and below, all right? It's always above minus below. Now, between 0 and 1, as you can see, this is the focused region in here. All right, the focus region. Now, clearly the curve is above the line. All right, so in this case, it's the volume above minus the volume below. And that will give us the volume of the solid. All right, so in this case, the volume of the solid is equal to, remember volume formula. First thing, remember volume is pi times the integral from a to b of y squared dx. That's when it's around the x-axis. That's a formula we need to remember. So in this case, it is going to be pi times the integral from 0 to 1 of the curve, which is x squared plus 3x minus 2 dx, minus the volume, pi times the integral from 0 to 1 of 3x minus 6 dx. Now we can always factor out pi and then work it out, but that's irrelevant. Depends how you want to do it. So let's say you want to factor out pi, then integrate. Well, I mean, doesn't matter. I'm just going to integrate. Pi times x cubed over 3 plus 3x squared over 2 minus 2x going from 0 to 1. Then we're going to subtract pi times the integral of, we integrate 3x, we get 3x squared over 2. And then when we integrate minus 6, we get minus 6x going from 0 to 1. So in that case, that implies the volume of the solid is pi times, let's put in the 1, that's 1 over 3 plus 1 times 3 is 3 over 2 minus 2 times 1 is 2. Then all of that we subtract. Don't need to put in any zeros because it's all zeros. So put in the 1 down here. 3 times 1 is 3, so 3 over 2 minus 6. And this is also being multiplied by pi. And so the volume of the solid is, just input that in a calculator now. One over 3 plus 3 over 2 minus 2. That part is negative 1 over 6. Pi minus the next side now. 3 over 2 minus 6. And remember, it's being negative, so minus that. That become plus 9 over 2 pi. They will add them. I want to keep my answer in terms of pi, so I don't want any decimal. Yeah, no, I pick and choose when I want decimal, but that's okay. 13 over 3 pi. That's the volume of the solid. 13 over 3 pi units cube. Remember, volume is units cube. So 13 over 3 pi units cubed. How much marks for that? Hopefully 7. 7, yeah, we like it. We like it. 7 marks for that. We take it. Alright, so that is that 13 over 3 pi units cubed. This one now, they want to find area. They say the curve below shows y equal cos x and y equal sin x. So they need to give us the graph because we know this graph from ATMA. And now they say determine the curve between x equal pi over 4 and 3 pi over 2. So first thing, let's look for pi over 4. This would be pi over 4 here. Pi over 4, pi over 2. Then this is 3 pi over 4. Then this is pi. This is 3 pi over 2. So determine the area between the curves. So now I'm going to highlight the areas between to show you. All right. Now, right here, right? Notice the area between the curve. Let me shade all of the common areas. In this region, this piece is common. All right. That's the common piece, right? It's the common piece. This is these two curves, that's between. And over here now, we have between. All right. Let me shade again. The between part, between the two curves. So these are the points of intersection. Always highlight the point of intersection. Then you can work out your between. This is an intersection point, and this is an intersection point. I'm looking if I see any more intersection point there, and I don't. So I know that we're good now. But we have a strange thing here. What's a strange thing? We notice that part of the area is above the x-axis and part is below. So what we're going to do to find this area is we're going to have to integrate up to this point. Then we'll stop. Then we'll take the magnitude of the integral below. All right. So always remember area is also above minus below. Which line is above? The black one, and the black one is sine. So in that case now for here, we have the area is equal to the area of the curve above minus the area of the curve below. So in that case, the area, and we're going to do it in two parts as we say now. So we integrate the above, the black one, integrate the above one, the black one first. So integrate, and this is starting from pi over 4 to this is pi. Integrate from pi over 4 to pi of above is sine x dx minus the integral of the same below now, pi over 4 to pi of the one below is cosine. The dotted one is cos. Then we're not finished. We're going to put now plus what now? Plus now we need to evaluate the integral for this piece. The integral for the shaded part below the x-axis. This part that are shaded in black, we need now to evaluate that part. For evaluating that integral, we're going to use modulus because that's going to give you a negative answer. But to account for the negative, we take modulus. So it's the integral of which one is above again, the black. So the modulus of the integral from pi. Alright. So the integral of, yeah. So the integral from, and remember in that region, we find an area between them. Alright. Determine the area bounded by the curves. Alright. So from here now we're going from pi to our 3 pi by 2. Alright. So we'll go from our pi to our 3 pi by 2. Alright. And in that case now, pi to 3 pi by 2 of our sine x minus our cos x. I don't have much space, so that's why I leave off the dx. So let's start with the positive part now, the part that's above the x-axis. So the area is This is the positive part. All right, so let's call it area 1, where I'm saying the final answer going to be area 1 plus area 2. Don't worry, you'll see what I mean. Area 1 is just the first part we're working on. Area 1, as I say, which is the integral from pi over 4 to pi, from pi over 4 to pi of sine x minus the integral from pi over 4 to pi of cos x. I leave off the dx, but that's okay. Well, it's not okay, but for space, it's okay. So in this case now, I'm writing it as one integral. So this is really sine x minus cos x, and we're integrating from pi over 4 to pi dx right there. And so now we're going to go ahead now and integrate. So we integrate sine and we get cos x, or negative cos x, and then we integrate cos and we get, when you integrate cos, you just get sine x. And remember, we're going from pi over 4 to pi. When you plug in pi, no problem, plug in pi. So we have, let me put the calculator in radians here. So put in cos pi, which is -1. So we have -1 minus, so put in sine pi, we get 0. And then we subtract when we put in now pi over 4. And when you put in pi over 4, all right, you're going to get minus cos pi over 4 pi over 4. We'll put that in, and we get negative root 2 over 2. And then we have our minus, and we put in for the sign would also be the negative root 2 over 2. Now all of this can just go in the calculator to give us a1. So in the calculator now we have -1 minus in bracket -1, close that bracket. All of that is going to subtract, open bracket, it is now negative fraction button, square root 2 over 2, subtract fraction button, square root 2 over 2, close bracket. I'll get 1 plus root 2. So that's a1, 1 plus root 2. Now we need to work out a2, and a2 is this black region that I shade, right? Determine the area bounded by the curves. All right, right there. All right, so now that black region that I shade, all right, that black region in there, well, actually, right here is from this black region. So integrate from pi by 4 to pi, yes. So good to go. Now in this black region, we need this piece. So we have to work out now this minus of that, yeah. Then we take the modulus. Key thing, we take the modulus. So I have more, very good, I have more space. Now a2 is going to be modulus of the integral from pi to 3 pi by 2 of the curve above, and the curve above was sine x, minus the integral from pi to 3 pi by 2 of the curve below, which is cos x dx. Remember, modulus. So now we'll go ahead and we do that. A2 is, all I'm going to do is, we already did have the answer. Integrate sine, we get minus cos x minus sine x. And all we're going to do is throw on the pi and the 3 pi over 2 equal now. And remember, we're going to take the modulus afterwards. So now we'll plug in the 3 pi over 2. Plug in the 3 pi over 2. Do it in a calculator. Cos fraction button 3 pi over 2. That's 0. So this is negative 0 minus sine 3 pi over 2. So change it to sine now. That's negative 1 to minus negative 1. Subtract. Put in the pi now. Cos pi, we said cos pi was negative 1. Minus sine pi, we said is 0. Then the result we're going to take modulus. So in that case now, what we're getting is minus and minus is plus. That's plus 1. Minus and minus is plus over here. So we have 1 minus 1, which is 0. So in that case, it cancels each other, no problem. And so what we end up getting now is that A is A1 plus A2, which works out to be the A1 plus A2. That works out just to be 1 plus root 2. And we'll finish. So that's the area bounded between the curve 1 plus root 2 units square. Alright, just make sure our computation is not off. Alright, please, we need to verify it. Alright, and verify that we didn't make any computation error. You verify it, you look back through, make sure we didn't make any computation error. Now, part C, it says, on the surface of the moon, the acceleration due to gravity is that amount and the rocket is launched. So first thing I like to do is write down what's given. They give me the acceleration. They tell me a rocket is launched with an initial height. So they give me distance, the initial distance. So the distance is 1200 meters. And they give me an initial velocity. Initial velocity is u. Now they say determine the velocity and the height of the rocket 5 seconds after launch. No, I don't know, but this is very easy. But again, this is odd math. The only thing you would have to remember is that velocity is u plus at. And we need the velocity after 5 seconds. So when t equals 5, then the velocity is the initial velocity 30 plus the, this is a formula, by the way. If you do physics, you would know. If you do add math, you would know. V is equal to u plus at. That's, easy to remember. And if you do applied math, you'll remember as well. So 30 plus negative 1.625. And then the time is 5 seconds. I'll put that in the calculator. 30 plus negative 1.625 times 5, and that is 21.875 meters per second. That's the velocity. Now, alternately, you could have integrated acceleration to get velocity, but that's too much work. I'm not in all that. Now, we need to find the height when it is 5. First thing we know is that the distance is equal to ut plus half at squared, or you can use s equal ut minus half vt squared. You can use whichever one you want. I'll use both. So when t is 5, remember, so when t equal 5, s equal 30 times 5 plus a half the acceleration, which is negative 1.625 times 5 square, which give you, put all that in the calculator, 30 times 5 plus a half negative 1.625 close the bracket times 5 square, and then you get this amount, 129, call it 130 meters, because we're going to put it to 3 significant figures, and this is 3 sig fig. Remember, the rule at the front said all calculations must be given to 3 sig fig. So even me putting this right here, the velocity is actually 21.88 meters per second. Make sure throughout the paper you keep putting 3 sig fig just to follow instructions. Or you could use ut ut plus half at square, and then I forgot to say vt minus half at square, sorry. Vt minus half at square, I wrote it wrong. So the velocity, 21.875 times the time 5 minus half at square. All right. We'll put this in our calculator. I'm quiet because it's just calculator now. I don't need to explain um, computation. So I'm just putting it in the calculator. Put in the calculator, and this is what we get, which is the same thing, 130 meters. Or there's even another way you could do it. And the next way is using another formula. You could even use this one. You could even say S. Let me see. All right, I'm having difficulty transposing, but you could say v squared is equal to u squared plus 2as. Then I transpose to say v squared minus u squared over 2a squared. Not square rooted, that's it. V squared minus u squared divided by 2a. That formula could also work. So you could use this as a formula to find the distance. You could say the velocity to 21.875 square minus initial velocity square over 2 times acceleration. So you can do any one, and I guarantee same answer. Alright, so I'm just showing you the multiple ways you could do this question. I'm not even going to finish it. We just know that we get the same 130. Put it in a calculator, try it, it will be. So that concludes this paper. Is there anything more to it? Page 28. I think 29 would be the extra sheet. There is something more to it. Sorry. So now this one now, determine this integral. Now at unit 1, there's only two types of integration I've seen come a lot, is either substitution or recognition. Now this one you can't just integrate it, so clearly it must be what? Substitution. So in this case now, realize that, well, if you differentiate sine, you get cos, so we can use u as sine 2x. So du is differentiate sine, you get 2 cos 2x, right? But then realize we have cos cubed there, so in problems. So therefore, this is not the best one. So then try the other way around. Alright? Because that's always a $1,000,000 question. Which one do you call u? Now, if you call u cos now, cos 2x, realize when you differentiate cos, you get negative sine. So in this case now realize, well, this is more helpful, right? This is way more helpful. Because when we're integrating now, cos 2x being cubed times sine 2x dx, we realize from right here, we could make sine dx the subject by dividing by negative 2. And so we have sine 2x dx is just equal to divide by negative 2. It is negative a half du, right? So now we can substitute it. So this integral, I like to call my integrals I. Cos 2x, where that is, you put u. Remember what we said earlier, it's u. And then where we see the sine 2x dx, that part we just worked out to be. We just worked out sine 2x dx, this part. We work it out to be this now, negative half du. So we can put that now as negative half du. And now it's easy to go. So now, in this case, it works out to be the integral of, factor out the negative half, And so we have u cubed out here. Integrate, add 1 to the power, divide by the power. So u to the 4 over 4 plus a constant k. Now in this case, now remember, half times quarter is 1 over 8, so minus 1 over 8 u to the 4 plus k. Then what was u again? Cos 2x. So the answer is negative 1 over 8 cos raised to the 4th power 2x plus your constant of integration. That's your answer. Alright, so that works out this question here. It's not bad, just to show you the full solution in one go on the screen. Here you go. It's not bad. Full solution for the previous question. No integration, we just did that. That is that. So I hope this video is beneficial. Make sure you're practicing. That's the only way you're going to get better on pure math. It's just practice, 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 more practice. All right, so stay tuned, and I'm out.